Identity and inverse matrices. So these are two little concepts, and they're quite useful, but it's not immediately obvious why they're useful. And before I go into them, I'm just going to remind you about some stuff about normal maths. You don't need to write this down. Normal multiplication is commutative. That means it works both ways. 3 times 4 is the same as 4 times 3. We already know that matrix multiplication is not necessarily commutative, that you can't necessarily do matrix A times B and also do matrix B times A, and you won't get the same answer even if you can. We also know in maths that anything times 1 equals itself. 3 times 1 is 3. I know I'm being really basic here. And we also know that there's things that can cancel out to equal 1, such as anything divided by itself equals 1, 4 divided by 4, and anything where we reverse the operation, so plus 3 minus 3, and anything multiplied by its opposite or its reciprocal. 3 times 1 over 3 is 1. So there's a bunch of things in normal arithmetic where we can cancel something out effectively to get 1 by doing either its opposite, multiplying by its reciprocal, dividing by itself. And things like that are quite useful. For example, in solving equations, we need, if I've got 2x equals 4, this is x times 2 equals 4. I need to be able to reverse that times 2 to cancel it out, to discover that x is 4 divided by 2, which is 2. So there's a bunch of things in maths that have similar aspects with matrices. So the identity matrix is kind of like the one of matrices, in that if you multiply any matrix by the matching identity matrix, it doesn't change your original matrix. Any matrix times the identity matrix equals itself. The identity matrix is called I. It's always a square. It can be any size of square. The elements on the leading diagonal, top left to bottom right, are 1s, and all the other elements are 0s. We're only going to deal with a 2 by 2 identity matrix, and it looks like that, but you can have any size of square identity matrix. So always a square matrix. The leading diagonal elements are 1, all others are 0, and multiplying any matrix, so we'll say matrix A times the inverse matrix is the same as matrix A. A times the inverse matrix is itself. Also, you can multiply the inverse by the matrix or the matrix by the inverse, and you'll still get the same answer. So multiplying by the identity. I went to inverse. Any matrix times the identity matrix is itself, and the identity matrix times any matrix stays as that matrix. So identity matrix multiplication is commutative. It does work both ways. So this is basically the one concept in matrices. Now, inverse matrices. A to the power of -1 is the inverse, sorry, there should have been a space there, of matrix A. It's like the opposite. And it's the opposite because matrix A times inverse A equals the identity matrix, the one matrix. And this is also commutative. The inverse of A times A still equals the identity matrix. And only square matrices have inverses. Now, this is quite handy in our next concept because we'll use it in the same way that we use doing the opposite of something or multiplying by its opposite to get 1 to solve equations. But for now, we're just getting this concept happening. We won't teach how to find the inverse. We use our graphics calculators to do it. So the questions we might have here: find the inverse of matrix A and confirm that A times its inverse is the identity matrix. So enter your matrix into your graphics calculator. I think I've already done it. 8432. Yep, I have. And I've also got an identity matrix in matrix B here. So first up, I can just check if I do matrix A times matrix B, I still get matrix A. So definitely A times the inverse still equals A. And now I want to find the inverse of A. So let's just hop into your matrix menu, get matrix A, and then helpfully the same key as the matrix key, x to the negative 1, is my inverse key without the second function, and it will calculate inverse A for me. So inverse A and confirm that A times inverse A is the identity matrix. So get matrix A. We can use times if we want, but if you just type them in next to each other, we'll get times anyway. Matrix A and make it inverse equals the identity matrix. And so A times inverse A gave me the identity matrix. So that is the identity matrix, the one concept, and inverse matrices that when multiplied by the original matrix give you the identity matrix.